Hello guys, today we're going to have a look at the k-means algorithm. The first thing is, as usual, I encouraged you to read the article that I wrote a few weeks ago about the k-means. You will learn how to install the right sklearn module. You will learn a bit of theory about it. So it's available here at this link. And you can see also a very visual way to understand what k-means does for us. Basically clusters seemingly unstructured data, so it labels them and puts them into a given number of groups, as you can see here. And last, in this article, you will see what methods and attributes you can use, and also a nice way to use it when you do NLP, natural language processing. So let's go. I prepared a notebook for today. So we will use a 2D dataset to help gain an intuition of how the algorithm works. Basically, we're going to create our own fake two-dimensional dataset because the human eye likes to see things in 2D or 3D. It's much easier for us to understand that more dimensions. So the first thing we need to actually cluster data is to get some data. To get this data, we're going to go here and we'll use a module from sklearn that is called make blobs. I prepared the doc for you, so in case you don't know about it, you can just check the documentation here, and you will quickly understand that the make blobs module generates random data points for us. Actually, not that random. It's using some Gaussian math under the hood, and it produces some data points that you can then plot using a scatter plot. And this is actually perfect for k-means training, as you will see in a minute. So let's use make blobs. So we quickly had a look at the documentation, and for today we will generate, as you can see here, 500 data points, and we want to cluster them into 4 classes. I mean, we know beforehand that we are expecting 4 classes. You can forget about this random state thing. This is to say basically that if I rerun my code, I would like to see the same random points. If I don't use a random state, then the points will change over and over. So we need to generate our points, and first we need to import the right modules. So for this tutorial, I will need NumPy. So as usual, the import is import NumPy as NP. This is to manipulate n-dimensional arrays. We will use matplotlib to make plots. And then from sklearn, we will use make blobs to generate the data points, and then k-means to implement the k-means algorithm on these points. So now that we have imported everything, we will actually generate points. So to generate the data, the syntax is the following. xy is equal to make blobs and then a number of arguments. If you're lost, a tip that I can give you when you are working in a notebook, if you want to check the documentation, you can just press Shift Tab like this, and then plus, and you have all the documentation docstring appearing for you. It's very handy. And so here I said I want to generate 500 data points. So n samples is 500, 4 clusters, which are called centers in the doc. And then I added this optional argument, cluster standard, which means the standard deviation of each cluster, and I set it quite small in this example to 0.5 so that we can see very easily the different clusters. I don't want them to overlap, basically. But this is an optional parameter, as you can see here. So the default behavior is to generate 100 data points and 2-dimensional data and a standard deviation of 1, etc. But you can tailor all of this. Then using matplotlib, I create my figure and I scatter plot all this, and let's run it. this is what I get. I get four data clusters in blue here. So to summarize, I've created a fake data set with 500 data points and 2 dimensions and 4 clusters and a standard deviation of 0.5. This pretty much summarizes my data points. So now we want to apply k-means on these points. The thing is, k-means requires a human input, at least an input that says, I'm expecting to see X clusters. And for now, let's pretend we don't know X, although we are expecting 4 clusters. So we need to find the appropriate number of clusters, because if, let's say, blindly I try running the k-means with 2 clusters, let's run this. You can now see that it's obviously wrong because we have 3 purple clusters and 1 yellow, and visually this feels wrong. On a side note, how did I color the clusters? I just used the C argument here, and I'm saying the color should be corresponding to ypred. And what is ypred? Ypred here is my k-means algorithm that I applied, and I actually used the fit predict method on X. Remember, X is my make blobs data points, and applying the fit predict on X means please observe X and then actually make prediction on the label. And so this yields an NumPy array that I can use as the color. And to check this C argument, I'm guessing if I shift tab it, should see in the docstring. If I go down, yeah, it says C is array like our list of colors. The marker colors, possible values, you could write a scalar, 2D array, etc. So because this is obviously wrong, I need to find the right number of clusters. In this case, it's very obvious. Sometimes it's less obvious. And a well-known way to do this in order to find the appropriate number of clusters is to use the elbow method that I use in the article here as well. So to use the elbow method, what we'll do is nothing else that running n k-means algorithm with n varying and being the number of clusters. For each of these k-means implementations, we will compute the inertia, which is a measure of the loss, and then we will actually implement the k-means that scores the best. This is the use of this for loop. So here I'm doing it with 10 k-means, and I'm saying every time, please iterate and start a new k-means, change the number of clusters, and append the loss, so the inertia, into this WCSS list that I initialized here as an empty list. So now let's run this. It's done in a third of a second. Like you can see here, it's quite quick. And now in this following cell, I will just plot my results. So this is what I get, and I can see that the best possible number of clusters seems to be 4, because that's the point where basically adding complexity, so adding an additional cluster doesn't bring much, because the inertia, the marginal inertia basically is 0. So now that I know that the best number of clusters should be 4, I just have to re-implement the k-means again using the 4 that I just found out. This is why I'm saying here ypred is my k-means, and this time n clusters is 4. Random state, as I said, you can forget about it for now, and then fit predict x. And then when I do my scatter plot, again I'm using this C argument. On a side note, you may have noticed that I used several times this semicolon here at the end of my plt dot something. This is used Let's run it. Yeah. This is used to avoid matplotlib from, like, to prevent it from printing some output. Let's see. If I remove it, now matplotlib has printed some stuff that I don't want to see. This is why we use this semicolon, so like a tip I can provide you. So now we have at last the correct number of clusters. You can see it's perfectly clustered, like the score would be 100%. And yeah, that's it. If you want to check the documentation of k-means, you can find it easily on sklearn. You will discover the many methods, the many arguments that you can use. And then once you have understood all of this, I think you're ready to go on your own coding journey and start clustering many things. Okay, guys, thanks for watching, and see you soon.